Thanks for joining us for NetApp on NetApp's Know-How series. In these videos, NetApp IT experts give overviews of core NetApp products and how to implement them. We've covered everything from ONTAP capabilities to Cloud Manager and more. To get a more in-depth look at previous topics we've covered, you can find all the previous editions on our channel under the NetApp Know-How playlist. Today, we are joined by Senior Storage Engineer David Tanigawa, who will discuss NetApp IT's Day Zero storage automation.
Hi, everyone. I'm Dave Tanigawa with NetApp IT. And so today we're going to talk about NetApp IT's approach to Day Zero storage automation. So when we talk about Day Zero, the concept is really around initial setup and provisioning, getting the basic setup in place so that the equipment is ready for use. So as far as NetApp IT goes, before the hardware arrives, we'll typically put together a design doc, which shows the card locations, the network cabling, the shelf IDs and connections. And we'll also request IP address provisioning from our network team. Then our data center services team will take care of the hardware installation and the cabling. When they turn over the equipment to us, we'll validate the shelf IDs and the disk assignments. We'll ensure that the correct version of ONTAP is installed, either to match our existing cluster or our current standard version. And then we'll run the cluster setup wizard to configure the cluster, the management lifts, set up the admin password and things of that nature. And then we'll go into the automation. We'll run our automation playbook to set our naming standards, our standard configurations and services, and our network configuration. So when we look at the general process of developing an Ansible playbook, the first step is to really understand the task that we want to automate. What components or services are we trying to address? What actions do we want to perform on those things? Next, we want to look at the Ansible modules that correspond to those items and how we can incorporate those for using Ansible. For the third item, we're going to write the tasks using the modules. Each task corresponds to an Ansible module. Fourth, we're going to structure our playbook. The playbook is a YAML file that identifies the hosts that we're working with, the tasks, the different actions we're going to perform on those hosts, and some other factors like variables and handling conditional actions. Fifth, we're going to test the playbook. So we run the playbook using the Ansible-playbook command and make sure that the playbook is executing properly. And then the sixth step is really to iterate and expand. In some cases, we may be adding roles for better organization. We may be incorporating some variables or some conditions or loops. And that's really the overall process of developing an Ansible playbook. When we look at some NetApp IT specific details, all of our Day Zero playbooks are run from an admin server. We have some playbooks that are really var files that serve as lookups to grab some of the values that we need to assign to our variables. And then we have an execution playbook that acts as the master playbook, executing all of the tasks that we are executing. And then once the playbook is run, we have a pre-release checklist that the build engineer will go through to ensure that the build is up to our standards. And we'll have a TOI meeting with our storage operations team to review the new nodes, to discuss what they're being used for, to address any questions they may have, and to make sure they're comfortable assuming operational support for the new nodes. As far as best practices, the playbooks don't necessarily need to be built from scratch every time. New system builds are things we do routinely. In some cases, we need to customize the playbooks for different use cases, but we can take a look at previously used playbooks and just modify those as needed for different use cases. So our Day Zero build playbooks, these are the Ansible modules that we use with those. These are not necessarily in the order that items are executed, but they're just kind of grouped logically by type here. Basically, our Day Zero build playbooks primarily address establishing our standard naming conventions for nodes, aggregates, and lifts, configuring network port properties, configuring our backup or intercluster lifts, our if groups, our VLANs, and custom broadcast domains. And then also setting up key services like SNMP, DNS, log forwarding, and things of that nature. We do use the ONTAP command module in places where there isn't a specific Ansible module to address a service or configuration we're trying to put into place. This command module just allows us to send an ONTAP command to the cluster to take care of those items that aren't covered by a specific Ansible module. All right, so let's take a look at a quick demo here. So here is a cluster that we're setting up, calling it cluster 1. It's a new C250 HA pair. And at this point, we've gone through the setup wizard, and I'm just going to show you what the cluster will look like before we run our playbook. So here you can see we have default names, node names, -01, -02, and the aggregates also have the default node names. The SPs also have the default node names, and then we have our default broadcast domain. So there's the cluster domain and the default domain with the two E0M management ports assigned to that. Our network ports have the default configurations as far as the bare port settings. And then as far as interfaces, we have our 4 cluster lifts on the 2 nodes, our cluster management interface, and the 2 node management interfaces, default node names. There's nothing yet configured for VLAN or DNS. We have the default UTC time zone. CDPD is not configured yet. Event notifications have the default settings as well at this point. Security auditing is also off, and cluster log forwarding is not enabled. All right, so now let's take a look at our Ansible playbook. So we start here at the top, prompting for a password for the user that will be configuring the new nodes, and we'll pass the host name, username, and password details to the Ansible modules that will be configuring the node. We reference 2 var files here that define the variables that will be used to configure these 2 nodes. We're going to start by renaming the nodes to our standard node names, and then we'll do the same with our root aggregates. So once our root aggregates are named, the next thing we're going to do is configure our service processors or VMCs. Then we're going to delete our ports from default broadcast domains. Next, we're going to set our standard network port properties, flow control, speed, duplex, and auto negotiate, and MTU size. Then we're going to create our VLANs. In this case, 4 VLANs for these nodes, a backup VLAN, and then 3 others. I think in this case, we have a management VLAN and 2 iSCSI VLANs. Now we're going to delete our VLAN tagged ports from the default broadcast domains, and then clean up those default broadcast domains. And then we're going to create our custom broadcast domains. We're creating one for each of the 4 VLANs that we've created. And then we're going to add our VLAN tagged ports to our custom broadcast domains. Next, we're going to create our backup lifts or our intercluster lifts. We use these for SnapMirror. Next, we're going to rename our cluster lifts so that they also incorporate the new node names. And our node management lifts, we're going to rename those as well to our standard. The next thing we're going to do is we're going to move the cluster management and node management lifts off of the E0M default port. And we do that temporarily so that we can remove the E0M port out of the default broadcast domain and clean up that initial default broadcast domain. Once that's done, we'll then move the E0M ports to our custom management broadcast domain, and then we can revert the lifts back to the E0M ports. We have to do this because as long as a lift exists on top of a physical port, we can't change the broadcast domain for that port. So next we're deleting the E0M ports from the default broadcast domain and removing that domain, and then assigning those to our custom management domain, and then reverting the lifts back to E0M. Once that is done, we're going to set up our services. So we're going to set up DNS, SNMP. In this case, we're just setting up a public SNMP community for demo purposes. We set our time zone and then enable CDPD. And we're going to configure event forwarding for Splunk. Then we also configure security auditing and cluster log forwarding. All right, so let's take a look at our cluster now that we've run the playbook. So now you can see that our host names have the N01A and N01B node names according to our standards. Same with the aggregates. Those also have the node names incorporated into the aggregate names. Our BMCs are configured. And our broadcast domains, you can see the default broadcast domain is gone, and our 4 custom broadcast domains are in place. And the VLAN tagged ports that correspond with each of those have been assigned to those domains. So these are the network port properties. So we've configured those as well. Our 4 VLANs for each of the 2 data ports on the 2 nodes, those have been configured. And once again, the broadcast domains, and then our network interfaces. So the 4 cluster lifts now have the right node names. Same with the node management lifts. And we can also see the backup lifts that we created with the playbook. All right, so next we see DNS is configured, SNMP is configured, CDPD is enabled on both nodes, security auditing is enabled, cluster log forwarding is enabled, and our event handling is also configured to forward to Splunk. All right, so once our playbook is run, the next step is for the build engineer to go through a pre-release checklist that just validates that the different aspects of the new node configurations have been taken care of. So those include some different networking areas, validating system access and security, data protection, licensing, making sure that our services are configured properly, aggregates, and monitoring. As far as playbook lifecycle management, there's really 2 aspects that are involved in that on an ongoing basis. The first being adapting to changes in the way ONTAP works, particularly when you're doing the initial setup. So ONTAP used to have individual license keys for different protocols and services. Now we have a single NetApp license file that we apply to the nodes. It used to assign all of the network ports to a single default broadcast domain. Now it uses multiple default broadcast domains. And then ONTAP also is providing some additional features as the product continues to mature. So now background firmware updates can be configured within ONTAP. So that's something we don't have to necessarily take care of as part of our automation. The other aspect to playbook lifecycle management is just ongoing improvements that we can make. So in one case, we added a second var file in order to reduce the number of items that we need to configure manually when we're switching from building nodes in one use case to a different use case. There's other customizations like that that we will incorporate over time to improve the capabilities of our playbooks and to incorporate other features.